Hi, this is Greg from Fraser Valley Climate Action, and I want to share this slide deck with you. It's by a fellow named Nat Bullard, and he does an annual report on decarbonization. And so he's pulling data from all over the place, all kinds of different things. There's a lot of focus on financials that I don't understand, so I won't try and explain them. But there's a lot of metrics that are quite interesting to see the state of things. Now, I'm just noticing I've got the January 2025, so that's the right date. I noticed the date above that is different, but don't let that disturb you. Mostly it'll be current data. So let's go. Okay, why isn't it going forward? There we go. In order to see climate change, we have to look at really long-term data. Looking at this year or last month isn't going to do it. So here's 1,200 years in Kyoto, where they actually record the day of the year for the full flowering of the Japanese cherry trees. And so you could see the records go way back. Records get a little spotty way back there, but you can see they've been recorded for quite a long time. And you can see there's a range where, some years it's earlier, some years it's later. There's always going to be that variation. But the 20-year moving average, so the average of the last 20 years, that's the blue dot. And so the blue dot goes up and down depending on, whether the years were warmer or cooler. So if you look at that trend, you could say basically most of the line is around 105. 105 days into the year, that's where you get the full flowering date. Look what happens towards the end, towards 2000. So you get where you're only 100 days, for the last 20 years, it's only been 100 days in, and then you get to like 95 days. For the last 20 years, it's only been 95. So this is really long range data. And what you can see is something changed in the last century. Something shifted that date as much as 10 days earlier in the year. So that's interesting. So the warmest year on record. So global surface temperatures were 1.6 degrees Celsius above the levels that they were in 1850 to 1900. That's one of the baselines. So you could see where zero is: 1950, 1960, 1970, 1980, 1990, 2000, 2010, 2020, 2024. So not only can you see that, yes, these numbers are above, but none of these numbers are below. And you can also see there's a curve there. You can follow that curve with your finger, and you can predict where it's going to go next. Oh, I'll stop clicking on it. It doesn't like clicking, sorry. Water vapor is one of the most common greenhouse gases. And when you have a hotter atmosphere, you have more water vapor in the air. So you can look at the percentage increase in water vapor in the atmosphere. And, we've got thousands of satellites that can measure this kind of thing, or well, thousands of satellites, some of which can measure this kind of thing. So we're getting some good data there. So you can see how that's changing. The number of extremely hot days has doubled. So 20% of days are extremely hot relative to 1961 to 1990. So if we take that time period and we look at this time period, yeah, it's getting hotter, right? Tripling in 60 years. The average length of a US heat wave season tripled. So the heat wave season was 20 days, and then it was 30, and then 50. So you notice this isn't going up and down, right? This is going up. That's the point. Long-term measurement shows a consistent trend. Carolina hot nights, 30 days a year with nighttime temperatures above 75 degrees. That would be the top one. And then you can see, if you go back to the 1990s, there was only, 4, 5. You get into the 2000s, it was 5. You get into, and of course, there's variation, right? Some years are cooler, some years are warmer. We'd expect that. You know about El Nino and El Nina, and how that might be changing the weather this way and that way. Heat waves mentioned in earnings calls in transcripts of India's NE 500 listed firms back in 2018. No, what is this? Quarter of 2018, 2019. Oh, there were 18 calls in 2022. That's what that one is. There were 80 in 2024. Could be popularity. Could be that they're having more heat waves. The dew point has risen. I don't understand the science here, so I'm going to just roll right past this. This is so significant, this one. Labor hours lost to heat exposure in 2023 were equivalent to 835 billion in potential income losses. That's so huge. So there's the labor hours lost due to heat exposure. And it's going up. So, think about businesses and think about them needing to get things done, whether it's driving a truck or building something in a construction site. They're losing the labor to do that, partly because of the increase in heat. So if you follow the blue line, the dark blue line, 2023, you see it sort of ends way down there and it comes back on the page in red, 2024. The Panama Canal's key water source was at its lowest ever January level in 2024, January being the far left here, right? So that's interesting. So they're just measuring, if you look at all the years in January, that was the lowest. Now, towards the end of the year, it recovered and, maybe they're going to be fine next year. But this was a significant event. There were significant events in 1998 and 2016 as well. But if you look at all the gray, that's all the other years. So if we're just looking at January, and that seems to be kind of significant, maybe that's when the waterfalls. Yeah, it's a significant change. Valencia, remember Valencia, Spain? They had that huge flood, and all those cars got washed into the streets. You might have seen pictures of that. So one day in October, they got more rain than the previous 3 years. 3 years of rain in one day. That's crazy, right? So yeah, our cities aren't built for this. More heat, less oil. Olive oil prices are spiking because the olives aren't doing so well. Pricey Java. When I look at this, honestly, I just see it going up and down. I don't see a clear trend here. Maybe you do. I'll move past this one. This is interesting. Record emissions from fossil fuel combustion hit an all-time high in 2024. So we know that burning coal is a really dirty way to make electricity. We know that burning oil pollutes the atmosphere. We know that burning gas also pollutes the atmosphere. So just look at this chart and look at the role of gas. Is gas contributing more today than it did in the past? Yeah, the pollution from gas is growing. So be careful of the marketing of the greenwashing you might see where people are saying like, it's clean, natural gas. It's not clean. It's also not natural. Um, we could talk about that some more. But look at cement. Did you expect cement to be there? Yeah, it's huge. And these are gigatons of CO2 emitted per year. Just as a side note, NASA says that the CO2 that gets put into the atmosphere basically stays there for 300 to 1,000 years. Like it's not going to get wiped out by a bunch of trees next year. That's the point. It's not there this year and then we start over from zero. Like it stays there. This is the challenge. And when I heard that, it changed things for me a little bit. So maybe that'll be an interesting insight. Okay. Well, what else do we have here? Global coal consumption hit an all-time high. Yeah, maybe I'll just go back for a sec. Like if you watch the news, you might think like, "Yay, we're making progress." Does this look like progress to you? Do you see the dip in 2020 when we had the pandemic? Yeah, everything slowed down a little bit. People weren't driving around. See lower oil. Interesting to see lower gas too, right? But maybe that's oil really. Maybe it's primarily people not driving around. Interesting. But it's getting worse over time. It's not getting better. It isn't being fixed right now. It's being made worse. And I think that's a key takeaway from this. We're not tackling the problem. We're not really making a big difference. We're still heading in the wrong direction. And that's really important for people to understand the next time somebody tries to sell them on the idea that oil and gas is a great idea. Let's do more. It's like you might want to understand the science better. So look at this, billion tons. Global coal consumption hit an all-time high in 2024. And look, China. Wow, China. You are outdoing us all right now in terms of burning coal. And China continues to put new coal plants up because they need the electricity. And because they are making steel and blast furnaces and other things like that. So there's some there's some idea that China is about to hit a peak and start coming back down. We haven't seen evidence of that yet. You can notice there's a little peak around 2012. That might have looked like success, but no, they're still putting new ones up there. So there's a little more to that story, and we'll get to that later. Look at what's happening in the US, a reduction in coal. Thank goodness. And the EU, good. And India's getting bigger. And I think that's the Association of Asian Nations. Sorry, I don't know the acronym. It's getting worse. The rest of the world, maybe getting worse, maybe staying about even. Hard to tell at the top of that graph. But by the way, this video will go 15 minutes. Indonesia's coal production has increased by 10 times since 2000. Holy crow, guys. So steam coal production. So they're burning it to make steam to produce power. It's too bad they didn't invest in, solar or something. So it's getting significantly worse in some places. Look at India going up while North America and Europe go down. That's kind of the same chart, just sliced and diced a different way. This is interesting. Now, we don't necessarily want aerosol pollution in the air because it does other bad things like sulfur dioxide. I think that causes global rain, acid rain. So if you look at this, we can see that we have warming going on here, and the aerosols are actually taking away from that. And we want to reduce the aerosols. So what does that say? It's going to go up when we take those away, right? So here it is. Look at those aerosols. Look what they've done, right? They were pulling things down a little bit, even while other things were driving it up, resulting in that red line that's in the middle. So it could be that the aerosols were actually hiding some of the global warming effect that the other pollutants, the methane, the CO2 were having in the atmosphere. Bit of a problem for us, right? Solving for sulfur. Sulfur emissions. Well, China's contributing quite a lot. I bet that has something to do with the coal. This is interesting for me. Look at how global wood fuel production, like growing trees just to burn them. So those trees, sure, they suck up some carbon in that, but then they get burnt and they put the carbon right back into the air. So those trees aren't doing a positive thing for the environment. You could argue that it's, closer to neutral because, we could ignore the fact that we have to use power to chip them up and transport them, and that the burning process isn't 100% efficient, but basically it's a problem. Also produces a lot of particulate matter. But some good news is if we look at, and they're calling it roundwood, I think that's hilarious. If we look at the percentage of wood that is just getting burned, that's going down. So we're down to 50% now. So, maybe instead of burning it, they're making furniture with it, or they're building a house out of it, or something like that. And wood is a good option for building houses because it takes that carbon and it stores it in that house for 100 years or however long the house lasts. But burning it, it's not a great idea. Maybe better than some, but not a lot. Now, I think this is sort of an interesting slide to end on. Working animals, horses pulling carts, basically. So this peaked after we had steam, rail, and autos. So I think this is kind of a good news story in a way. Like, we're seeing oil and gas and that sort of thing still kind of going up and getting bigger. We do have solar today. We do have wind. We do have nuclear. We do have hydro. We have cleaner technologies that we can and should be using. Absolutely. So it could be very discouraging to see these other things going up and peaking. But just because something is cleaner or better for the world or better for our community, or in the case of solar, cheaper, doesn't mean people are just going to switch overnight. So it might take some time. But then it did come down, right? So I think we'll end it right there. We'll just end it on the working animals. Thanks for your time. Take care. And yeah, come visit us at FraserValleyClimateAction.org, fvclimateaction.org, and you can learn more.